how do I build this data platform that can help me build the data lake, right? So the data lake is just part of the problem. You still need a lot of peripheral tooling around collecting data from these different sources. There is, your data, even though you stored it in some format when you ingested it, it may actually need to evolve based on usage patterns that you may have, either query patterns or access patterns. And then you want to monitor performance of data lakes. You want to monitor patterns of ingestion, correctness. So essentially, you want to build some data observability modules so that you can actually see what's going on and make sure that what you're doing is right and it's utilized to the best of the abilities. Talking about maintaining all of these, we run into these problems of, okay, we have stream use cases, batch use cases. And now I have to maintain these multiple technologies, and there's a bunch of operational overhead. Is there some way we can sort of unify some parts of the stack? And so the question is there a single system that can manage, and do all of these operations, but at the same time provide some sort of unification in stream and batch? So let's look at requirements of the data lake, right? So you want hassle-free data ingestion. And ingestion has many challenges. You have multiple different types of sources: Kafka, raw file dumps, upstream. How do you build a system that just plugs in all of these components? You want to auto scale for spiky traffic, right? Or for maybe organic explosion and growth. You want to perform schema management. One of the important things of having a data lake with which you can use to derive insights is to have high quality, trustworthy data. And that starts at doing schema management to know what data you're ingesting. And then you need custom transformations, for different kinds of business rules, and sort of you want to update some table based on some sort of logic. And then at the end of the day, you want to provide observability and support different kinds of query engines out of the box, so that you can connect different kinds of query engines, access this data based on use cases you may have. I talked a little bit about unifying stream and batch. So let's talk about that a little bit more. So a typical Lambda architecture is, batch is great for slow moving data. It's, of the order of tens of minutes. And then, stream style processing is generally of the order of some sub-second latency. And then you generally use, you get stream data, you solve the use cases that you have for low latency data, but then you treat batch as your fallback, right? And there are different kinds of processing engines that you would use for that, and that's totally fair. But what about storage, right? So stream systems need some sort of specialized databases or maybe specialized systems, and are in many cases row-based, although some of them are also columnar-based, but in many cases row-based. And batch systems are generally columnar-based because they tend to be slower to write, but are really good and efficient for scanning. So what about use cases between 1 and 5 minutes latencies? Typically, at Uber, we realize there are lots of use cases that fall within this time bucket, and then there isn't a solution that streaming tends to be an overkill, whereas batch tends to be too slow. So is there an architecture? And there's a suggestion in the community that Okapa architecture is about unifying processing. But what about unifying storage, especially for use cases that lie in this kind of latency? And the final one I wanted to go over is, do you just write once and read many in a typical data lake? That's what we do. But what happens is you get stuck with the initial data layout, and they may not be best for your query pattern because that kind of layout may have been best for ingestion latency. And it may not be the most efficient for specific types of queries. For example, you want to query on user ID, but the data is actually split based on event time. So you want to adapt your data lake based on what are the needs of the data lake. So you may want to ingest fast, but then you want to reorganize your data based on query needs. And you want to do all of this without blocking readers and writers, so the business continues uninterrupted, but you keep tuning the efficiency of your data lake. So the question to think about is, do the data layout and query patterns have a strong connection? And in many cases, we realize they do. And this isn't a new concept, like databases, where you have online stores work this way.